Hi, Unassimilated here. Rabbit Ape did a nice little video about odds of things happening, and he used dice to show how unlikely it is to get a random sequence. And yeah, the odds are pretty incredible. Well, I've been meaning to do this for a while. I'm going to do something similar, but I'm going to do it with cards, and I'm going to show you the odds against what happens right this second. I'm going to be performing a miracle, so here, stay with me. I'm going to point the camera down here. So we've got ace of... Here we go. I'm not going to call them out because it'll take too long. I'll just lay them down. We're getting a sequence of cards here. 52 cards. So here are all these cards in this particular sequence. Now, what do you think the chances are of this having ever happened before? What do you think the chances are of this exact sequence ever happening again? You might be a little surprised to find out how unlikely an event this is that I am performing right now in front of your very eyes. There we go. There are 52 cards. So let's figure out what the odds are. Well, you know, with the first card, there's one chance in 52 that it will be the 10 of clubs. And then with the next card, there's one chance in 51, since one card's missing, that it's going to be the ace of clubs. And then there's one chance in 50 that it'll be the 3 of spades. Alright, so this is called a factorial. You do 52 factorial. So it's 52 times 51 times 50 times 49, etc., all the way down to times 1. Or you can go the other way.
So you multiply that all out, and you come up with a figure of 1 in 52 factorial. But what does that mean exactly? How big a number is that? Well, the answer is it's very big. It's one chance in 8 with essentially 67 zeros after it. The problem is when you get into numbers this big, it's really hard to comprehend what that means. So I've decided to try to put this in perspective. Let's pretend that we could go back in time and we could perform this experiment in 1 second. So we're going to do it once every second since the beginning of time. Well, I did this and the number was still too big, so I decided let's make it even more interesting. Let's say we're doing it once a second since the beginning of time, and we're doing the experiment simultaneously around every single star of the known universe. Okay, so how many stars are in the known universe? Let's start there. Right now, it's estimated that there are approximately 7 with 22 zeros after it. Could be 7 with 24. It could be 24 zeros after it. It's somewhere in that ballpark. But let's go with the lower number for now. It's not going to matter that much. So we're doing this experiment around every star, and yes, I know that there weren't always all these stars. In fact, for the first 300,000 years after the Big Bang, the theory is that there was no matter whatsoever. But let's just pretend these stars have always existed, and we've been always doing this experiment once a second since the beginning of time. Beginning of time, of course, is 13.7 billion years. We'll ignore leap years since it's not really going to matter. And so we get all those seconds. So we take all those seconds times all those stars, and that's how many times we're going to perform this experiment. And all we have to do is divide that giant number we had at the beginning, and we get the chance of this sequence that you just saw occurring at least once through all those experiments. And what we end up with is a number that's still unbelievably huge, but it's a little easier to deal with. It's 266 quadrillion, 518 trillion. So we would have to continue doing this experiment for a really, really long time before the odds even got close to being even. So was that a miracle? The odds against are incredible. But no, clearly it's not a miracle. And the reason it's not a miracle is because it was just random. We dealt things out, and that's what we got. The problem comes in when you look at things in the wrong direction. If you made a prediction that you would get that sequence of cards, and then it came up, well, yeah, that would be a miracle. That would be incredible. This kind of backwards way of looking at things is often used as proof of God. A good example is fine-tuning arguments, and a lot of arguments against the probability of evolution. You get people saying that, look at this universe, it's designed perfectly for us. If gravity wasn't this strength, and if we didn't have this much oxygen in our atmosphere, then humans couldn't exist. If we didn't have a certain amount of water and carbon, etc., then it would be impossible for us to be here commenting on it now. The problem with that type of argument is that it presupposes that humans had to exist, and that's kind of ridiculous. If things had been a little different, or if things had been a lot different, let's even say that some of the constants of the universe were different, and we ended up with a very different universe. You might end up with some other intelligent life form eventually coming up that had a very different atmosphere, very different chemical composition. Maybe it was silicon based, maybe the atoms were all different. It doesn't matter. You'd end up with this intelligent life looking at all of the parameters that had to be set a certain way so that it could come into existence, so that it could evolve. And it would look at those numbers in wonder because it's looking in the wrong direction. And it would proclaim, there must be a God.